Okay, so naive Bayes algorithm is one of the classifiers. Okay, we basically use for classification. Okay, and it's one of the very popular algorithms you can come across. Okay, so after finishing this unit, you should be able to know the components of the Bayes theorem. Remember when we did mathematical foundations, we looked at the Bayes rule of probability. You remember? Okay, so this algorithm is built on that. Okay, so you should be able to explain the concept of conditional probability, and then we will apply the naive Bayes algorithm and be able to make predictions of outcomes based on conditional probability. Okay. So basically, what is naive Bayes? So it's also a classifier, a supervised machine learning classifier, okay, which is based upon probabilities, okay? So it is based upon the idea that the predictor variable in a machine learning is independent. Okay, so here the main thing is that there is no, it assumes that there is no multicollinearity. Okay, the variables do not correlate in any way. Okay, they don't correlate in any way, and basically that is why it is referred to as being naive, because in the real world there will definitely be some correlation among the predictors. Okay, so that is where the term naive comes from. That how can you say that all the predictors are independent of each other? All right. Nevertheless, in spite of this assumption, naive Bayes is a very popular algorithm out there. Okay, because it is a simple technique, right? And the performance is normally really good. Okay. So what are some of the use cases of naive Bayes? So naive Bayes can be used for spam filtering, test classification, okay? How you categorize documents, can be used for sentiment analysis, recommendation systems, real-time predictions, even medical diagnosis. Today we'll be doing some medical diagnosis, okay? Image recognition, credit scoring, anomaly detection, and so forth. So these are some of the use cases for naive Bayes. Okay. So it's really a fairly popular model, all right, being used out there. Okay. So like I said, the naive Bayes algorithm is based upon the Bayes theorem. Is based upon the Bayes theorem. All right. And this involves the use of probability, okay? Probability and conditional probability to be specific, okay? Conditional probability to be specific. So we'll go into that. Just remind ourselves of what we did and mathematical foundations, if you remember, the Bayes theorem, okay? If you want to find the probability of A given B, okay? We don't know A, we want to find B. But we have information on B given A already, okay? So it's a probability, I think, let's remove this brackets, this guy here. Yeah. So it's the probability of B given A. So if you want to find the probability of A given B, is the probability of B given A multiplied by the probability of A, or divided by the probability of A. Okay? So the probability of A given B, you know, is a conditional probability of event A occurring, given that event B has already occurred. Okay? And then the probability of A is the probability of, or PA is the probability of the event A occurring. And that of B is the probability of B occurring. And then the last one is the conditional probability of B occurring, given that we know A. All right. So what Bayes' theorem does is that it starts from a condition where there is known, then it moves to the unknown. All right. So you want the probability of A given B. All right. We don't know that. But since we know B given A, okay, we can work it and then extend our knowledge, okay? And then based upon that, we can get A given B, okay? So where probability, the Bayes theorem or the naive Bayes works best is, when there is new information. So you might have some information, existing information, and then when new information comes to light, it's able to add this and then, be able, based upon the new information, be able to predict what is going to happen based upon the old information it has. Okay, so it starts from somewhere, okay, somewhere where it has some information, then it moves to the unknown. All right, okay, so that is the basic concept behind the naive Bayes. So let's look at some of the terminologies. Okay. So A is referred to as the proposition. Okay. A is the proposition and B is the evidence. All right. So we don't know A. We want to find A. Okay. So A is the proposition and B is the evidence. All we have already. Okay. So A, the PA represents the prior probability. Okay. We know the probability. And then B is the prior probability of the evidence. So we have the prior probability of the proposition and then the prior probability of the evidence. Okay. And then the A given A is a posterior. That is what we don't know. Okay. That is post. Okay. Is the posterior element. Okay. And then B given A is the likelihood. That one we know the probability already. So we know the likelihood already. Okay. All right. Okay. Any questions so far? Any questions so far? Okay. So if we take the formula for the Bayes theorem, okay, and then insert the terminologies alongside, okay, then we can say the probability of A given B, okay, is the probability of B given A, all right? Probability of B given A multiplied by the probability of A, or divided by B. In the same vein, we can say that the posterior is equal to the likelihood multiplied by the proposition of the prior probability, okay, over the probability of the evidence. Okay. So let me go through this. If it's a bit technical, don't worry. When we take an example, I think you can relate with it. Okay. So suppose you have M class, okay, of C1, C2, C3, okay, up to Cm, okay, and you know the probability of the classes, okay. So C1, C2, so you have the probability of C1, probability of C2, up to Cm. So if you know the probability of the occurrence, okay, so we have a vector of S1, S2, S3 within a class. By using a Bayes theorem, you can calculate the probability that the record belongs to a particular class, whether C1, C2, C3. Okay, so with each class, there are attributes in those classes. Okay, and so knowing these attributes, you will be able, so this is the one that is known. So based upon the attributes that you know, you can work to determine that this particular attribute belongs to this class. Okay, so basically everything that we've done here, okay, is what is replicated here. Okay, but in this scenario, okay, we're looking at various classes. Okay, so we have C1, C2, C3. All right, here the mathematical formula was just looking at one case. Okay, so C1 is a prior probability belonging to the class of C1. Okay, okay, in the absence of any other probabilities. Okay, so in order to classify a record belonging to the Bayes theorem, you compute its chance of belonging to each of the class in CI. That is either C1, C2, C3. Okay, and then classify it based on the highest probability score calculated using the preceding formula. Okay, so we will take this. Sounds a bit abstract, but let's take a practical example. Then, I mean, this will make much more sense. Okay, this will make much more sense. So let's say we have a sample training set. Okay, a sample training set. Now, these are the items you have. You have the ID. These are the features. You have the ID. You have the purchase frequency. You have credit scoring. You have the age of the person, and whether approval was granted or not. Okay, approval was granted or not. So we have credit rating. Okay, we have the age of the person, and then we have information on how frequent somebody purchases some items and whether they were approved, okay, for a credit or not. All right. So basically, this is what we have. Okay. So the data samples in this training set have the attributes of age, purchase, frequency, and credit scoring. Please, are we all okay with the information we have here? Are we all following?
Yes.
Yes, Nana, we are following.
Okay. So the class attribute has two distinct classes. So in terms of the class attributes, we have no or yes. Okay, so we have two. We have two binary classes, okay, or cases. So C1, okay, remember we're talking about C1 and C2 classes here, okay? So here, C1, okay, correspond to the class approved, okay? And C2 correspond to the class denied or no. All right, so we have one yes, and then we have one no. So using the naive Bayes classifier, we want to classify an unknown label, okay, sample S. So based upon this information, we want to predict if somebody is more than 40 years and somebody's purchase frequency is medium and the credit rating is excellent, okay, will the person be approved or not? Okay. So we know this information on the left. This is what we know. Okay. This is what we know. And then we want to go into the unknown to find X. Please, is it making sense? Okay, so we have some unknowns. So based upon this information, we'll be able to, calculate some conditional probabilities. And then based upon these ones, okay, we'll be able to go into the realm of the unknown to determine X. If somebody's age is more than 40, the purchase frequency is medium, and then the credit rating is excellent. So how do we go about it? So here our probabilities will come in. Well, let's see. First of all, you notice that we have 14 observations, isn't it? We have 14 observations. Now, how many observations in terms of classifications? How many do we have for yes? If you can count it.
I'm counting 6.
You are counting 6. Okay, good. All right. So we have 6 for yes and then 8 for no. Okay, is that okay? So we have 6 for yes and then 6 for no. So first of all, let's determine the probability that the approval is yes. Okay, so the probability that the approval is yes, you count as 6, isn't it? Will be 6 over 40, is it not?
Yes.
Okay,
Yes.
so we'll get 0.428. Okay, so we have our first classification, the probability for the first classification. What about the probability that the approval is no? We have 8 entries, isn't it? So
Yes.
8 entries divided by 14 will also give us 0.571. Are we okay up to now?
Yes, Nana.
Okay. So now let's deal with the conditional probabilities. Okay, let's deal with the conditional probabilities for the 2 classes. Okay. So remember that we have a lot of features here. So let's first of all take the age. So if somebody is above 40, okay, given that approval is yes, okay, so for the approval yes, we have only 6, isn't it?
Yeah.
So within that, if somebody is over 40, what will be the probability? So that means we count our 6 and then we go and check the ages above 40, which is yes. Okay, so how many do you count here in the age column?
2.
You see 2. Okay, so therefore the probability of being 40, given that approval is yes, is 2 over 6. Do you agree?
Yeah.
That's 0.33. Okay, please, if you are stuck on anything, just stop me. Okay, now let's check for the probability that the person is more than 40 and then the approval is no. Remember that the number of no's was 8, isn't it? All right. So if you check over 40 here and it is no, let's see.
Yeah.
The first one is here. 6 and 10, yeah? Okay, so also 2. Okay, so that will also be 2 over 8, is it not? That gives us 0.25. Okay, so now we've done for age. Let's go on to the next one. Let's do for purchase frequency, medium. All right, so the probability that purchase frequency is medium, given that approval is yes. Okay, so here too, we know that approval yes is 6 entries. Okay, so here you have to go and check medium out of 6. Okay, how many do you count? 13. Okay, good. So that means it's 1 over 6, isn't it?
Yes.
Yeah.
Okay, so 1 over 6. So the probability here is 0.16. Now let's check medium if approval is no. Medium if approval is no. So here we have a couple of them, isn't it? So we have
1, 2, 8, and 12, 5.
And 2, 5. Okay, so that will give us 5 over 8. Do you agree? So the probability of purchase frequency being medium, given that approval is no, is also 5 over 8. Now let's go on to credit rating. Okay, so credit rating, remember that all this we are picking is because of this prediction we want to make. Okay, so we have taken over 40, we have taken medium. Now let's go and take excellent. Okay, so probability that credit rating is excellent, given that approval is yes. Okay, so here too we check approval yes is 6. Okay, we know that. So how many excellents go with it?
5 and 7.
5 and 7. So that is 2, isn't it? So that will give us 2 over 6, which gives us a probability of 0.33. All right. Now, if a credit rating is excellent, given that approval is no, all right, Then that one too, within the no's, we have 8. Okay. So how many excellence do we have for no?
3, 2, 10.
3 of them.
3,
12.
2, and 10. Okay.
And 12.
2,
2, 10, and 12.
2, 10, and 12. Okay, so that gives us 3. All right. So that's 3 over 8. So it gives us a probability of 0.375. Are we okay up to now?
Yeah.
Okay,
Yeah.
so now we've calculated the probabilities. We've also calculated the conditional probabilities. Okay, so these are the ones we know. So using these probabilities, we can obtain the following. We can determine the probability if approval. So for us to determine that approval is yes, we take the yes, the probabilities of every of the yeses, and then we multiply. So first of all, the approval of the loan being yes, okay, is the approval of the loan, okay. Sorry, the
And are we taking the conditionals or just the main probability?
Sorry, I think we'll take the conditionals. Okay?
The conditionals, okay.
The conditionals, because that's where the given is. So given that approval is yes, we have 0.33 for the first one, okay? And then
Yes.
another conditional probability
Yeah,
yes is
0.167.
0.167, and another conditional probability of 0.333. So this is what we have here. So these are the conditional probabilities, okay, for a given sample of X. For a given sample of no, okay, here to we take the conditional probabilities of all the no's. We have 0.25 for this, okay? And then we have 0.625 for that. And then the last one is 0.375. That gives us this, okay? Therefore, the conditional probability of, for example, X, given that approval is yes, okay, times the approval yes itself, okay, will give us this. Will give us 0.009. So we take all the conditional probabilities and then we multiply by the approval yes. Okay. And then when it comes to no 2, we take all the conditional probabilities and then we multiply by the approval, by the no, all right, which is 0.7571. Then when it has done this, it takes the one with the highest probability and then classifies it as such. So here, if we take these two, okay, you will see that which one has the highest probability?
The given no.
The given no. Okay?
0.033.
So because of that, the naive classifier predicts approval is equal to no for a given set of sample X. Okay, so you see that this is just for just one prediction. Okay, so imagine that you have about 1 million rows. Okay, imagine that you have for 1 million rows. The naive Bayes classifier will do it for all of them at once.
Nana, please, the calculation for the approval no times approval no, the last but one line is 0.05.
It's 0. The approval no
0.
by no.
Yes, that please.
Okay, so it's
0.86.
Yeah.
Okay, all right. 0.0586, yeah? Please, can somebody else also check it and then we confirm?
Nana, please make
Nana,
it
you've
big.
calculated it at the top, so you just repeat it.
Oh, I don't get you.
Like 2 lines above where we are talking about, that's the figure there.
I'm lost though. So, okay, this one.
The second step.
0.0,
The second step.
Yes.
0.0586.
So that one has to come to where you pointed earlier.
Oh, okay, so I made it 0.5 here. Okay, okay. So it has to be 0.0.
Yeah,
Okay, I get you.
but the answer is the same.
Yeah, I think it was a
0.04246.
typo. Yeah. Thank you. So please, do you get the mechanics of how it works? So everything that was discussed here basically is this that we've done. Right. So this is just for one prediction. Okay? This is just for one prediction. So imagine that you are doing it for high, low, fair, okay, between 35 to 40, less than 35. It's a lot. Please do get me. Because here we just did it for one prediction. Okay. So the naive Bayes classifier would do all that. Okay. So let me send a couple of this sample to you, and then we see how we can apply this practically in our R studio. Yeah. Any question? Any question on this? Okay. Just a minute. Let me send you this. Let me send you. So I've sent you two data sets. So one is a diabetes data set, and then the other is the training set. So let's use the training set for now. So please import the training set to your studio. Okay. So let me share our studio. All right. So there are a couple of libraries you should read into R. But first of all, install the ML bench. Okay, so install both packages. ML bench. Okay. And then when you finish, call it from the library. You could also install the psych package. Use it for something. So when we finish, I think these libraries we have them, we should have them. So we have the ML bench. Psych. Our good old friend, tidy models. We'll use it for the splitting. And then our parrot. So let's run these guys. So I already have this, so I don't need to install. So let's run these guys. Yeah. Oh, sorry. That's a Y. It's psychometric. Okay, so we have okay. So let's read our data to I call this T. Let me set the working directory. So let's just view T. Okay, so I set it to you as an RDS, okay? So use read RDS, you know how to do that, okay? All right. So, yeah, what is this guy telling us? So we have, so it's the same data set I showed to you, okay? So we have the purchase frequency, credit rating, and then the status, okay? So basically, let's assume that this is a training set, okay? Let's assume that this is a training set. Let's see.
Please, can I see the package you installed?
Yeah. This one, ML bench, and then psych. The rest, I think we have them already. But let me also use read RDS. Okay, so let's add our glimpse. A glimpse should be working. Didn't we run tidy models?
Nana, isn't glimpse part of? Okay.
Yes, I was wondering why it wasn't working. So I think I didn't run the ID models. I didn't run. Around psych, around.
Or should we try the structure STR?
Or you can also do that. But the glimpse should be working. I didn't run tidy models for mine. That's why I didn't work.
Oh, okay.
Okay, so, all right. So we have this. Okay, so let's build our model. Okay. So we have status and then we have the rest. Okay. So the status is the outcome variable. Okay, and then we have the rest. Okay. So predict the naive-based prediction. Okay, so what we want to predict is the purchase frequency was medium, isn't it? And then credit rating excellent, and then age 40. Age was
above 40.
Okay, good. So let's do for purchase frequency. Okay. So this is medium. Right? And then our credit rating. Our credit rating was excellent. And then our age was more than 40. Okay. So let's run these three guys. Okay. So let's put all of them together into a data frame. So data.frame. So we have purchase frequency. We have credit rating. So this will be like our T, our test set. Okay. And then our age. So let's call this C tests. Okay, so let's run this. Okay. So we have our test set. Let's call this test. Okay, we already have our train data to be T. Okay. So let's build our naive Bayes model. Okay. So say naive Bayes. So the outcome variable is status, isn't it? Tilde everything. Okay. Then our data is equal to T, remember? Okay. That's for the training set. So let's call this naive Bayes model. So NB model. Let's see the one for 30 models. I wanted to use the one with LM bench. Okay. Let me see. Did I run the LM bench? Let me run this. Hmm. Yes. There's naive Bayes in parsnip, okay? And there's another naive Bayes in ML bench. But it seems because we run tidy models, it's clashing with this. Okay. Are you having the same difficulty?
Yes, please.
Yes.
Yeah, okay. Okay, so I think
Nana, mine worked. You see, at first you used naive underscore base. That
yes,
one
that
didn't work for me, but this one worked.
okay. Because probably you didn't run. Did you run tidy models? You didn't run tidy models, so probably I think that's why you.
Oh, okay.
So the parsnip in tidy models is like conflicting with the one for ML bench, but that is I want.
Nana, I run tidy models.
You run tidy models, really?
Yes.
So let's run.
Nana,
Yes.
I think the naive base you are using, that one works with the E1071 package.
So which means if you were using support vector machines earlier on, then that means you already had it in the system. So that's why. Okay, thank you. Should be fine now. Okay. So now that we have created our model. Okay, we can just call it and see what we have here. So you see that it has calculated the conditional probabilities for all of them, okay? For all the features, for both high, low, for purchase frequency, it has done high, low, medium. For credit rating, it has done excellent, there, okay, and also for the no and then for the yes classes. Okay, at the click of a button. So it has the priori probabilities. Okay, yes, no. All right. So basically, it has given us this. So we have the prior probabilities also available. So we can go and do our prediction. Yeah. So prediction. Okay. So predict. So we have our model. We have our model that is NB model. Okay. We have our MB model, and then we compare it with the test. Okay, so the test is this, the purchase frequency being medium, credit rating excellent, and age over 40. Okay. So we'll call this spread. So let's run this. Okay. So what is our prediction? Based upon the conditional probabilities, will it be you, no, or yes? Okay, so it predicted no. Right. So basically, that is how it works. Okay. So this one was for just one prediction. Okay, based upon this criteria. Okay. It's just one prediction based upon purchase frequency being medium, credit rating being excellent, and then age being over 40. Okay. So if somebody is over 40, and even if the credit rating is excellent, and then the purchase frequency is medium, we predict that the person will be declined any credits to buy the goods. Please, any question? So you see how it builds upon conditional probabilities and then goes on to it goes on to do the prediction. Okay. Okay. So let's take some practical example, right? Another practical example. This was a quick one for you to just understand. So import the other data sets. So here we want to do some medical diagnosis to predict whether somebody might have diabetes or not. Okay. All right. So let's import what we have. Oh, this should. Okay. So example 2, yeah. Okay, so let's read that data set into our R Studio. What is the name of the data set, please? Can you give it to me?
Naive-based diabetes.
Right. Like this, yeah?
Yes, underscore diabetes. That's RDS.
All right. So let's call this GB. So let's view this. So here you are seeing pregnancies column. So this basically like the number of weeks that the person is pregnant. So the glucose level, okay, we have blood pressure, we have skin thickness, insulin levels, BMI, diabetes pedigree function, we have the age of the person, and then the outcome, whether the person has diabetes or not, right? So this is information we have about our patients. Okay, so we want to use naive Bayes to predict whether a patient that comes in with some particular conditions might be diabetic or not. Okay. Okay, so let's check the structure of the data set. Make some comments. DB. Let's check it first. Okay, so we have a structure here. Okay, so this is not what I wanted. Let's do the summary instead. Okay, good. So let's look at the variables. So pregnancy, minimum value is 0, maximum value is 17 weeks. Glucose, so I think we are okay here. Everything is fine here. Okay, so let's check whether we have some missing values in the data. Sum it up. So basically, there are no missing values, okay? So we can go ahead and split our data. Okay. Okay, so we have our tidy models in there already. So let's use our initial split. Initial split. DB model, okay? Or probability. Maybe 175. And then our strata will be the outcome, isn't it? Yeah, this one, this guy here. Oh. So we call this DB split. Okay. So let's go ahead and do our training sets. And then our test set, okay? So we have our DB split. And then we pipe that into our training function. Okay. So let's call this DB train. Okay. Yeah. So let's do the same for the test. change this to tests. Yeah. And this one is testing. Let's run this one to 25% goes in here. All right. So let's build our naive Bayes model. Build our naive Bayes model. Okay. So our naive Bayes. Okay, we have here the outcome tilde everything, yeah. With our data being the trained data. So that's DB3. Okay. So let's call this NB model 2. Yeah. So let's run this. Yeah. So now that we've built our model, we can now predict. So predict with naive Bayes classifier. So we predict our NB model 2, and then we run that on the test data, remember? Okay. So that is our DB test. And then the test we are only running the outcome column, okay? So DB tests. Okay. So you just pick the outcome column. Outcome. Okay. So let's call this naive Bayes predict. Pred. Yeah. So these are warnings. A lot of warnings. Okay. Let's check on something. What's the name of the what's DB? Yes, affected the outcome. That's what it affected when I created the RDS. So, okay. So let's see our pred. Yeah. Okay. So we have the levels. Okay. So we've done our prediction. So let's see the model evaluation. let's see how the model is working. So let's use our confusion matrix. Okay. So we use our confusion matrix, and then we are predicting. We are basing it on the end predict and also the actual outcomes. So DB tests. The DB test, and then we are picking the outcome. Sorry, we are picking the outcome column. Yeah. Let's run our confusion matrix. So it gives us our confusion matrix here. Oh, everything is, it can't be, everything
Yeah.
is,
Oh, it's weird.
Very.
okay. All the predictions are false. Okay. When you check the glimpse, this one is factored, isn't it?
Yes, Nana. My question was, why was R trying to ask us whether all the other ones too were affected?
The other ones.
Yeah.
So we are interested in the outcome variable. So I was just wondering why. Let me see. Because the BMI and the others were all numbers. Have you seen? They were all numbers. And then when you check the, I did some cleaning on this data set. So I don't know whether that is what is causing, but it shouldn't cause this problem. I did some cleaning on there. Let's see. Let's see our test data. Yeah.
I have one question. When you look at the data sets for the prediction, for the model, after building the model, it's giving us access to probabilities for each of the columns. Could that be causing the issue as you are comparing it to
The predictions, this one.
Yes. No, the model itself. If you view MB model.
MB model 2.
Yeah, so
yeah, that is the output that it gives you the probabilities for the, let me see. There's something wrong. The conditional probabilities themselves should not be giving us I did some cleaning. So if it's going to, I don't know whether the way I save it in RDS. Let me send you the CSV, okay? The raw data itself, and then let's work on that one, okay? It might take some extra 20 minutes or so, but I think it's worth it, okay? Let me send you that. Let me say, I did some working on this. I didn't want to bother you with the cleaning stuff. I don't know whether how I save it in the RDS is having an issue. Okay, so let me send this quickly to you. Okay. And then we compare the two and see. Okay, so I've sent it. Bring it into our and then let's work on it. Let's work on it. The RDS was supposed to preserve everything with all the cleaning stuff we've done, but I don't know whether it's happening. Please, have you received it? So now this will be read.csv.
No.
Yeah.
Yeah. So why I was asking the question that initially was, if we are predicting with the data, why aren't we using all the data by just using only the outcome column of the test to predict? Why aren't we using all the?
We are using all. That's why we have the dot here. This one.
No, down the prediction. Go down a little.
Yeah.
Yeah, the predict. You said predict MB model 2, DB test, and then you specified only the outcome field instead of using the whole.
Yes, because that is the that is the. Oh, okay. Oh shit. You see, what it does is that if we are, because we are going to use this for the confusion matrix, have you seen? So the confusion matrix takes the actual outcome. Okay. Please, are you following?
Yes, I follow that.
It takes the actual outcome and then the one in the model.
Yes, but Nana, wouldn't that come in the confusion?
Okay, I get you now. I think that's what, okay. I think that's what was percentage. Okay, I get you now. So let's run that. Yes, it's true. Let's run that. Because I was wondering how, so we have some true here now. Okay. So now we have some, okay. There. But that has saved a lot of cleaning work to do. I thought it was because of the cleaning. All right, so Thank you very much. So we have derived the confusion matrix. Okay? And then you see that when it comes to predicting positive classes, it does well. Okay, so we have the specificity and also the sensitivity. Let's look at the overall accuracy. The overall accuracy is about 78%. Okay, so this is the confusion matrix, which looks good. Okay. So yeah, basically that's the performance of the model. Let's see. So from these features, which one has the most influence on the model? Okay. So yeah, we can bring in our variable of importance. Okay. Right. So let's see. S, and then our model NB model 2, yeah. So let's start. Mhm. Okay. I was trying to. Okay. Sure. I'm having issues with my variable plot. Yeah, it's a carrot. Okay. Are you having the same error I'm getting here?
Yes.
Okay. I wonder why it's like that, because okay. Hmm. Just a minute, let me find out why. Everything seems okay. I wonder why the variable plot is not plotting.
According to ChatGPT, because of the package you use, the E1701.
Because of the
The E1701.
uh-huh.
Yeah. But
Oh, but we
the
run carrot. This one is under the carrot package.
yes,
Didn't you?
standard carrot, but they won't work because we ran the we trained the model using naive base from E1.
I can't hear you properly. Oh. You said that ChatGPT says that because we run the E171.
Yes. We are the plot you are trying to run is in carrot, but then we train the model using the naive base from E1701, so it won't work.
Oh, okay. So okay. So because we didn't use the carrot naive base. Please, can you come again? Hello?
Sorry.
Yes,
Yes,
please.
because we used we use naive base from E1701 instead of from carrot. That's why.
Okay. That's oh, that's we could use the one for caret, but I don't know whether should we use it so that you see how that one too is used. I don't know.
Yeah, I think we can try that.
Okay, all right. And let's do that. We'll use the model 3. Okay. Okay. Just a minute. Just give me a minute. Get this. Okay. Okay, so let's build this using the caret one. Okay. So, oh, sorry, let me share. It's already 9. Wow. We'll finish in the next 5 minutes. Okay. So this one is syntax is quite long. Okay. The other one looks a bit easier. So here we use a train function. Okay. So with this one, we had to actually separate. We need to separate the tests. Okay. We need to separate the outcome from. We need to separate the outcome variable, okay, and also that of the train one. So we call one X and then we call one Y. Okay, so let me do that quickly. And then we come and input it here. Okay. So we separate all the numeric variables. Okay. So it's here. DB. Okay. So I did a glimpse here, this glimpse, and then it's giving me, you see the 9 columns of what we have already. Okay. So what I was trying to explain, we separate the outcome column from the numeric, from the other predictors. Okay. So let's say we call the other predictors and remove the 9th one, that is the outcome column. Okay. So we'll be left with only the predictors. That will be our X. Okay. And then down for the outcome column, basically is you are taking the whole data set, and then you just zero in on the outcome column, and that will be our Y. Okay. So we come and put it into this argument. Okay. So the train XY naive base. Okay. So we have the training control, which takes a cross value, and it's a bit long, and the syntax is a bit abstract. So that's why I was staying away from this. But I wanted us to plot the variable plot. So let's use this. So let's run this. We run the X. At least I getting the same output as mine. Hello?
Nana,
Yes.
the train control should it be together?
Yes. This
Okay.
one. This one.
Yeah.
This one. Yeah. So it's a function.
Oh, okay.
So run it from yours, and then we see.
I'm not getting an error.
You are not. Yeah, I'm also not getting an error.
Okay.
Please, all of you, run it, and then let's see. Okay.
Hi, Nana.
Yes.
Could you put your screen back on, please? You are.
Oh, okay. Yes. Yeah. You wanted to see here?
Yes, right there.
Okay. So now that we have built the model, we can predict. Okay. So we use the predict function. Now our new model is NB model, and then we use it on the test data. So let's run this. Okay. And then we derive our confusion matrix. So we name this NB predict. Okay. So when we run our confusion matrix, we are seeing this. Okay. Giving us this. So the accuracy of our model basically is 79%, or let's say 80%. Okay. About approximately 80%. Okay, this one. Okay. So let's now plot our variable importance. We run this. Okay, we plot. Okay. So you see here that glucose in terms of the model, okay, glucose is the most important variable, which helps us to get this accuracy of 80%. All right, followed by age and then BMI. I think the least is blood pressure. Okay. So yeah, basically that is naive Bayes. So what we've done is that we've looked at how the naive Bayes algorithm works. We looked at Bayes' theorem and spoke about the fact that it is based upon conditional probability. We start from a place of known to unknown. Okay, so when we given some set of conditions, if new information comes to light, we can base upon the old information we have, okay, and based upon that, we can work out the probability in the light of the new information that has come about, right? So we looked at the various components of the naive Bayes algorithm, all right, okay? And we went through a situation where we wanted to do only one prediction, okay? And then we saw how they looked at the various conditional probabilities of classes, okay, within the outcome variable of interest, okay? So after that, we applied that to a medical diagnosis where we predicted whether somebody will have diabetes or not based upon certain conditions that the patient has, okay? And after that, we were able to plot the variable importance plot. Okay, we generated a variable importance plot, and then we realized that glucose is a very significant variable in determining the accuracy of our model. Okay, so followed by age and BMI. Okay. So basically, that's it for naive Bayes classification. Any question on what we have done?
Please, this is not a question, but can you please go up on your editor a bit?
Where enlarge it? Which line?
Like from here going down.
Down like this?
Yes.
Or, okay.
No, yeah. It's okay, thank you.
Okay.
Nana, I think there was a package we needed to also install in order to run this train thing. Oh, mine gave me that I had a missing package, KLAR.
Oh,
Yeah,
okay,
same.
okay. Normally, okay, when you do it, you click yes, and then it will install it for you. So you had to install it manually.
Yes, I had to install it manually.
Oh, okay. I remember that when you're using, normally it gives you, it pops a question that, do you want to install it? And then when you click one, it does it for you. You did it that way, yeah? Okay. So,
Yes.
all right.
Nana.
Yes.
So the previous method and this method,
Oh, they are all the same.
Both of them, yeah, both
Just
of them.
that this one, you are able to plot the variable of importance. That's the advantage.
But my issue is both of them are eventually landing me in the same error whenever I try to run the transfusion matrix.
Oh,
It's
that's so.
saying,
Okay.
yes,
Okay,
the data and reference should be factors with the same levels.
Okay, so
I
when
encountered the same
add the
error in the
outcome.
previous method too.
okay,
I added the outcome.
I'll have a look at it.
Thank you.
Please, any other question? Okay, share your screen. Okay, all right. Do you know what we'll do? If for those of you who have some questions, I will stay and then explain. Okay, I think let me help you now so that we all finish together. It's getting late, so share your screen. Let's see.
Oh, Nana, I think I can just wait for your quotes and then I'll try and swim my way out.
Okay. Then if you have any issues, then okay, that's wonderful.
Thank you.
So if it's an issue of factors, you can just create factors. Check your glimpse. Is outcome factored already? Because the RDS that I sent, I had factored the outcomes for you.
That is true. In my RDS, it's an integer. Okay.
It's
All right,
factored.
then let me quickly. No, it's not
So
factored. So let me
really,
quickly
your
do that.
RDS is not factored. It should be factored.
The
It is
RDS
an
was
integer.
factored, but the other one, the recent one we are using is an integer.
The recent one, you mean the? Oh, okay. Yes. Okay.
The CSV. Yeah.
Okay. No, the CSV is an integer. You see, that's why I was saying
Yes.
that the CSV, I cleaned it. There are so many things in the CSV, so don't use the CSV.
Oh, okay.
There are so many things. I cleaned it for us to have the RDS. You see, the RDS preserves it the way you've done it. So I cleaned everything and then saved it as an RDS. Other than that, we would have spent more time in doing the data cleaning. But that is not the focus of this lecture. Okay. So please use the RDS.
RDS. Okay,
Yes. Use the RDS and then you get all the stuff we are getting here. Because I had to do a lot of cleaning. So I mean you can just check what we have here and then compare it with the CSV. And then you will realize that a lot of cleaning has been done. What I did was that if you check the original CSV file, okay, if you check the summary, you realize that a lot of the variables had minimum number to be 0. Like glucose was 0, BMI, some of them had BMI to be 0, some of them had insulin to be 0. So what I did was that I imputed, you cannot have somebody without any glucose. It's not possible.
Course. Of course.
So what I did was that I imputed all the zeros with the mean. Okay, so if you take glucose, I replace all the zeros with the mean glucose. If you take insulin, I replace all the zero insulin with the mean glucose, and so forth. All right, and then when I finish, the original data set, the outcomes were zeros and ones, so I factored it and then made it how do you call it? I mapped them to.
True and false.
You are having false, true, and false. All right. So all this data cleaning has been done behind the scenes. I didn't want us to concentrate on the data cleaning. I wanted us to concentrate on the. So a lot of cleaning has been done for us to have the RDS. Okay.
Okay, then I think I'm good.
Okay. All right.
Listen.
Yes, Christiana.
Please kindly move up a little for us.
Like this. Up like this.
You move up. Yeah, we want to see what is down.
So I should go down.
Yes, there. Yes, please.
Okay.
Yes, thank you. It's a little up a little.
Up a little. like this?
Yeah, thank you. Yeah.
I will send you the comments. Don't worry. All this are there. So I'll send you.
Then sir, can I see the last one? The last plot with it seems
The
X.
variable plot.
Okay. Thank you.
Okay, you're welcome. Okay, so can we discuss the assignment briefly?
Yes.
Oh, ready.
Of course, Nana. Of course.
Okay, let's discuss this.
No,
Why
go
you
ahead.
don't want to do assignment? You people, you don't want to do the assignment. Okay, let's discuss that briefly and then should be fine. All right, go ahead. So it's a bit similar to what we did earlier on. So, our first semester exam assignment. So we'll wrap up very soon, okay? Then next 5-10 minutes. Okay. So moving. Please, can you see my screen?
Yes,
Yeah.
Nana.
Okay. So basically, so this is okay. So you have to send it. I think the last time there was an issue with the email address. So send it to the same place, BDA class 24. Okay, BDA class 24@gmail.com. So same as always, the deadline is 31st July. So you have about 6 weeks from now. Okay. So please don't submit it late. The other time, some people submitted theirs late. And, no, you are my people. So please, this time around, don't submit it late. Okay. Okay. So your task basically is everything we've done for this semester. Okay. So select and merge at least 2 data sets of your choice. Okay. And run 3 different machine learning models, at least 3. Okay. On the merge data set. conduct an EDA, and build supervised machine learning models that are able to predict your selected outcome of interest. You are supposed to perform feature engineering, okay, including at least one nominal predictor variable. All right, and then evaluate the model's performance. So you have the model's performance and recommend the best performing model. So you are to use 3, okay? Choose from here. You could use a linear regression, logistic regression trees, decision trees, random forest, support vector machines, neural networks, a nearest neighbor, naive Bayes. Choose any 3 of these, okay? And then use it on your merged data set, okay? And then check the model performance, and then recommend the best performing model based upon your results that you have, okay? So this constitutes 40% of your marks. Okay. This is a work in the park for you, isn't it? So this will be
Is with the data set, do we use any data sets, or you give us a data set to work with?
No, you go and look for your own data set and then merge it. So I don't expect 2 people to have the same answer.
Very big.
What is begging about this one?
Now, why the merge?
You say?
Why the merge?
Yes, in the real world, you
Yes,
don't
why
just
the
have one
merge?
data set. In the real world, you don't have just one data set to work. You have to import here and there and then merge it into one data set. Okay? So I'm just equipping you for the future. In the real world, if you are working, you don't go and then you just collect one data set and you are working with it. You have to get data sets from the various sources. So you need to find a way to merge the 2. All right?
Okay, sir. So if you talk about data set, are you mentioning like if we find students table data and then maybe we go and find lecturers table data and then the 2 we merge them? Is that what you're referring to? Something like that.
So what I mean by merge is take 2 different data sets. Let me know the sources where you are taking these 2 data sets. Okay. And then merge them. When you merge them and you begin to build the your models, any of the models that you want to use it on at least 3 of them. Okay.
Okay. Okay, sir.
So let's say you want to predict the sales of a particular retail shop. You can take the weather information and merge it with, let's say, the retail sales. All right. Okay. And then do your predictions. Right?
Okay, sir.
Please, any other question?
So it means that the data there should be a bit of relationship between the data.
Yes, so you have to find a relationship. Yes, so you cannot just take any 2 data sets. But the thing is that you have to, you know how the merging is done. Okay, so some of the data that you get, there are some you might have to aggregate the data in order to help you to be able to merge. All right, so you need to work on your data. Okay, so depending upon the data set you get, you can do either aggregation, or there are some that you might be interested in some few variables. Anything, just let me know how you did it. Okay. Because in the real world, that is what pertains. Okay. You cannot go and somebody will just give you a CSV file for you to work with. Okay. You have to pull data from various sources to put them together to do your prediction.
And Anna, please, the last one I want to ask, should it be one R file with a different models, or should be separate for the models?
So let's say, typically you've gotten your 2 data sets. Okay. So all the merging should be done within the R Studio, so that when I'm running it, I will see the same thing that you've done. Okay. So when you are done, send a zip file of your actual data set, because I'm going to run it. Send a zip file of your actual data set and then your R codes. All right. So when you are done, you summarize everything on PowerPoint slides, not more than 10 of them. Okay.
Nana, so what I'm saying is that when we pick an R file, it should contain all the models that we used, or we should separate the models to different R files.
Everything should be there. Don't separate them. Just do everything. So just do your comments and stuff like that. All right.
Okay.
Do your comments and I will follow. I will run everything and then follow. Okay. Please, any other question? Okay, so I would like to use the opportunity to thank all of you. Okay, it's been a very pleasant ride. All right, so I've enjoyed your company, and I hope you've learned something. All the courses I've taught you, first semester, second semester, I hope it will help you in your journey to becoming a fully fledged data scientist. Okay, and I'm happy the way some of you have picked up already. And I'm sure that your other courses are also equipping you. Okay, so all the best, and I hope to see all of you at your graduation, and then we can all celebrate together. Okay.
Nana, please,
In the meantime, if you are stuck on anything, okay, please do not hesitate to contact me. All right, and then I'll do the best I can to help. Please, Christiana, yes, any.
Yeah, now we beg.
Say, I also want to say thank you for having the patience to teach me. I'm very, very, very grateful.
Christiana, I will never forget you.
Thank you so much. I've really learned a lot. Thank you. Thank you. I'm very, very grateful.
Good to hear. Okay. All right, guys. So have a nice.
Okay, Nana, please. Last one. The exam structure, how is it going to be so that we can?
The exam structure is going to be like what the others have been. So most is a combination of theory and also you will be having outputs for you to explain the output and stuff like that. Okay. And remember, we've done about nine models. Okay. So I'll be setting questions on all of them. Okay. So please go over everything. Like I've told you, I don't know whether your results are out, but some of you did very, very well. And for those of you who did very well, I knew that you were active in class. Okay, so if you are active in class, please, you will do well. Okay, so just go over whatever we've done, practice, and also the theory bit, don't forget about it. Okay, because the theory is the foundation of the practical, right? So go over your slides, and also don't limit yourself to just the slides I give you. Okay, read books and then articles and things we've done just to equip you more. Then you'll be fine. Okay, you'll be fine. So if anything, you are reading anything and you are stuck, please do not hesitate. You have my contact. Do not hesitate to get in touch with me. All right? And I'll gladly help.
Thank you so much, Nana.
Thank you.
Anna,
yes.
This has been a great honor. God bless you for everything.
Oh, good. May I know the one speaking?
Nancy.
Okay, Nancy. Okay, good.
Thank you very, very much.
Thank you, Nancy. Thank you, Nancy. God bless you. Okay, guys.
Thank you, Noah.
I will see you when I see you. Okay.
Okay, Nana.
Okay. Have a nice
And we'll come and look for you.
Okay, all right. Okay, Michael. All right. Take care then. Cheers.